complex, but just to explain what's going on. For the treater, we have a first order treater, first order crossover, which means we have a capacitor and a resistor in series with the treater and nothing else. So there's no impedance correction, there's no EQ filtering, there's no phase adjustments. It's not needed for this design. And if you start Googling first order crossovers, a lot of people will tell you that you cannot do that because you're putting a lot of energy into the treater that the treater can handle, well, this treater can handle it. So that's how we make this work, simply by making a good enough treater. On the woofer side, we have a second order. Sorry? This particular one is 2.8, but 2.8 first order. So again, if you compare, the interesting thing is if you have a 2.2 fourth order, let's say, then maybe at 1.8 you would still have less energy than our 2.8. So the slope matters a lot. So because it's a straight up first order, you still have quite a lot of energy below 2 kilohertz, which not every treater can handle. And normally, when you make a first order crossover, we have a lot of extra components to make them work. If you look at our old first order crossovers, they are not this simple. Because to make it work, you just have to adjust a lot of things. Now we have some drivers that are better aligned naturally, so we have to do less work to adjust them in the crossover. On the woofer, it's technically a second order crossover, but it's not a traditional one, it's a low Q crossover, so actually it's like starts as a first order, and then we introduce the other first order later. We call it a low Q crossover. And that means that, again, we have very few components, very high quality components, an air core inductor, and then we have these two capacitors, which are from the Danish company Duelund. If you know about crossover components, Duelund is top shelf. They are more or less around the corner. If you want to talk to them about capacitors, they can tell you about that. And then we have a few interesting parts here, which are the resistors. So these PCBs you see here, this is actually one resistor, but it is made out of a lot of SMD resistors, SMD components. And this is a Dynaudio invention. We call this ultra precision array resistor, or UPA resistor, so that will be our marketing name for that. So SMD components have never been made and been used in this way before. They are very, very precise. Technically, this is what's called a MELF resistor, if anyone knows about electronics. It's a metal electrode leadless phase resistor. This is regarded as the highest quality component in low-level signals. The inspiration from this actually came from looking inside audio precision analyzers that we use to measure various types of audio equipment. So they, of course, have to be very exact and have very low tolerances. So with this array, we fixed the solution of, sorry, that doesn't make sense. Fixed the problem of this is low-level signal. So we would normally not use that in a loudspeaker, but if you have enough of them, now we can utilize the benefits of these low-level resistors and make them have enough power for use in a loudspeaker. And the benefit is that this acts like one resistor, but it's made out of many. We can design this part to have any value we want. So instead of being limited to the values that are on off-the-shelf resistors, if we want 4.95 value, then we just design that. And we don't have to settle for 4.7. So the other benefit of this is that we have extremely tight tolerances on this type of resistor. So where a loudspeaker resistor would normally be maybe 2 to 5% plus minus tolerance, if you have enough money, you might be able to get a plus minus 1% tolerance. This one, depending on the model, will go down to plus minus 0.2%, which is an extremely tight tolerance for a resistor in this one. So this has never been done this way. So yeah, this is something we will definitely use going forward. Another benefit of this type of resistor is the heat, the way it handles heat. So when this heats up, it releases the heat again very quickly, which is of course a benefit for music, because music is not just a steady state signal unless you listen to really boring music. Then music will be varying, it will have impulses and transients. So this makes it more consistent over time. It makes it more consistent with the dynamics of the music, and we hear that as better impulse response and a more consistent sound overall as the music changes. So, any questions to that barrage of technical information? No? Okay, then I'll try to demonstrate the benefits of these improvements. Since our iPad is charging, I will need to pull out my phone and play some music for you. All the music I'm playing is streamed from Cobus. I'm using a Moon 700 series system to demonstrate this. Moon is on the upper second floor as well, where you will find them playing on another set of Dynaudio speakers up there, the Contour Legacy. The cables are all from Chord Cable Company. The first track I want to play is, if I can find it, this is a German band called Can. It's actually a 55-year-old recording, but it's a recording that I think shows off very well the clarity we have in the mid-range, and especially on the three-way models we have an improved, smoother bass response. And when you hear this simple bass notes, it can seem simple, but sometimes some of these notes, as they go up and down, some notes are overwhelming more than others and things like that. So on this track, on the speakers, it sounds more like a bass playing music instead of sounding like a speaker playing bass. So hopefully you can follow that when I'm starting this up here.
Yes, I can.